Dear students, yesterday we saw one video about the introduction of road estimating earthwork. Okay, today we will go in some detail. So, cross section of the earthwork of road in banking or in cutting is usually in the form of trapezium, and the quantity of earthwork may be calculated by the following methods. So quantity or volume is equal to sectional area into length. What is the sectional area? This is the area of the trapezium, and how it is found? By simple mathematics. Okay, and with sectional we have to find sectional area and we have to multiply by the length to get the required volume or quantity. How to find this sectional area? So area of the central rectangular portion plus area of two side triangular portions. Okay, so when we substitute the area of the rectangular plus the area of the triangular portions, we get BD plus SD square. And slope S is to 1 is the ratio of the slide slopes as horizontal is to vertical. So for one vertical, horizontal is S, for D vertical the horizontal is ST. So here you see the figure. So remember this figure. If the depth D or the height D is equal, then we can directly take this formula. If there are difference, so at one side it is D1 and at another side it is D2, then what we have to do? Here author says we have to take the mean height. Okay, we have to take the mean height, that is d1 plus d2 by 2, and we will get the mean height as dm, and we have to substitute that dm in the sectional area formula to calculate the quantity. And we here come across some new terms like lead and lift. So lead is nothing but the earthwork is estimated for 30-meter lead. It is nothing but the 30-meter distance, and for lift it is 1.5-meter lift. So for normal lead and normal lift, we will define it is defined as 30-meter distance is the normal lead, and 1.5-meter lift is taken as normal lift. Okay, for greater lead, if the distance is more for greater lead or lift, the rates will be different for every 30-meter lead and for every 1.5-meter lift. Okay, now for the calculation of the earthwork in longitudinal section and the cross section of the ground are taken and the formation line is fixed. So during this calculation of the earthwork, so formation line is fixed. What is this formation line? Where the road is going to be fixed, or the surface of the road, or we can take as the lowest depth of the road after it has been formed. It is based on the consequences in the field. Okay, so the formation line, it depends upon what? The formation line is fixed in consideration of flood level, gradient, height of the bank, depth of cutting, etc. Okay, in plain countries means where the ground is plain, usually banking is done. But if the road is in cutting for some length and banking in for some length, then the excavated earth from the cutting portion should be utilized for banking portion within the economical limits during the execution of work. Okay, in hilly countries, road is usually both in hilly countries road is usually it comes both in banking and in cutting, and the excavated earth from the cutting is utilized for banking within the economical limits. Fine. So next para you can see from the L section and formation line, height of bank and depth of cutting are calculated. This height of bank and the depth of cutting are calculated from the ground level and the formation line. The difference between the ground level, RL of the ground, and RL of the formation line gives us the height of the bank, which is an important point which we'll get to know in when we solve the problem. Okay, and next important thing is So for longitudinal section, RL of the ground is usually taken by leveling instrument at every 30 meter apart along the center line of the road. At every 30 meter apart along the center line of the road. So what does it mean? For every station to station, the difference in the distance is 30 meter. When the ground is fairly even, when the ground is plain, so we can take up to 40 to 50 meter apart, or when it is uneven or in the hilly areas, we can take as 20 meters or more or less depending upon the nature of the ground. Okay. So now we shall see the three methods. Okay, for calculating the sectional area. So method one is mid sectional area method. Mid, as the name indicates, middle sectional area method. Here quantity is equal to area of the midsection into length. So let D1 and D2, we have saw on the earlier diagram. So this D1 and this D2, D1 is the height at one end and D2 is the height at another end. So by keeping that figure in the mind, so let D1 and D2 be the height of the bank at the two ends portion of embankment. L is the length of the section, B is the formation width, S is to 1 is horizontal is to vertical is the slide slope. Then area of the midsection is equal to area of this rectangular portion plus area of two triangular portion. So we will get the quantity of earthwork as area of midsection into L. Okay. So this is the tabular form for which we are estimating the quantity of earthwork. So we have 8 columns in which first column is for stations for chainage. So depth, we will get this depth by how? By the difference between the RL of the ground and the RL of the formation. So mean depth, if we calculate the average from here, station 1 to station 2, we'll get the average. Then area of the center portion, we know the B formation value, and D we will get from this column. So B into D, and S into D square. S is the slope, D square is the depth or depth of height or depth of cutting. Okay. So total sectional area, length between the stations. So quantity, either it is embankment or it is cutting. So for the clear picture, when we solve the problem, we will get to know that. So if the area of the slide sloping surface require turfing or pitching, what we have to do? We have to calculate it in different estimating form. Okay. So why this pitching is done? To maintain the slope. Okay. Here we come across two types of formula. Here the mean sloping breadth and the area of breadth of side slopes. So here also one tabular form is there. Station depth mean breadth of the slide slopes. Here it is d into root of s square plus 1 breadth of side slopes. Okay, length of between the stations and total area of both the side slopes. We'll getting this, and for quantity, by when we get the total area, we are multiplying with the rate. We'll get the estimated cost for that. And we come to second method, that is mean sectional area method. So first one is mid sectional method mid sectional area method. Second one is mean sectional area method. What we do here, there we took d as the depth, or it may be height. Here we are taking full area, so quantity is equal to mean sectional area into length. I told you to remember the diagram here. In mean sectional area, they are taking this one separately and this one separately, and they are combining the area. They are not combining, they are not taking the average of d, they are taking the average of area. Okay, so for sectional area at one end, it is a1 is equal to bd1 plus sd1 square, and for section at the other end, it is a2 is equal to bd2 plus sd2 square, where d1 and d2 are the height or depth at two ends. Then we have to find the mean sectional area by taking average, and then quantity by multiplying length for the area which we calculate, and we have to tabulate in this form. Same tabulation form. Okay, station, height, area of the central portion, area of the sides, total sectional area. So here we will getting this one extra column, mean sectional area, because here mean depth is not there, mean sectional area will get. So length and quantity. So next we will come as for the third method, which is called as Prismodel formula method. This Prismodel formula method is an accurate method compared to the other two. Okay, this is accurate method, and the difference is less than 1%. Okay, for both method 1 and method 2, I'll let you know later. So what we do here, we have the formula, the quantity or volume is equal to what, L by 6 into A1 plus A2 plus 4 am. So where A1 and A2 are the cross-sectional areas at the two ends of the portion of the embankment of a road of length L, and EM is the mid-sectional area. Mid-sectional area, it should be fine. Let D1 and D2 be the height of the bank at the two ends. I have shown you the figure, no? Same figure. Just keep that figure in your mind. Now DM be the mean height at the midsection, B the formation width, S is to 1 is the side slope. So for at one end, A1 is calculated. A1 is equal to, this is BD1, D1. So BD1 plus SD1 square. For the area at the other end is A2 is equal to BD2 plus SD2 square. So cross section at the middle. For middle, it is DM, where DM is D1 plus D2 by 2. So for AM, we have taken AM is equal to BDM square plus BDM plus SDM square. Okay, then we'll find the quantity. L by 6 is equal to A1 plus A2 plus 4 am. So what we get, sectional area of the central portion plus sectional area of the slide slope portion into length. We are getting at the last the result as this. Okay, now we saw the three methods. Method 1 was mid sectional area method, method 2 mean sectional area method, method 3 Prismodel formula method. And this Prismodel formula method is more accurate than the other two, method 1 and method 2, but they will differ by less than 1%. As the earthwork is a cheap item, method 1 and 2 are generally used as it is simple and entails less labor, but where rates are high and greater accuracy is needed or it is required, Prismodel formula may be used. Okay, just to distinguish cutting and banking, cutting is indicated by the negative sign. I will tell you what is to be done in the problems. Okay, now we'll go to the first example. So example number 1. So here what they have given, calculate the quantity of earthwork for 200-meter length for a portion of a road in a uniform ground, the height of banks at the two ends being 1 meter and 1.60 meter. The formation width is 10 meter, side slope is 2:1. Fine. Assume that there is no transverse slope. Okay, what they have given? They have given the formation width B is equal to 10 meter, side slope S is equal to 2, and length they have given as 200 meter. So what? Now we have to calculate the quantity of earthwork. So we'll calculate this by both, by all the methods, by three methods. So method 1. So what we have given details, B is equal to 10, S 2, L is 200, mean depth D 1 plus 1.6 by 2 will get 1.30. So quantity is equal to BD plus SD square into length. So substitute it, you will get around 3276 cubic meter. By method 1 we will get 3276 meter cube. When we come to the method 2, mean sectional area method. So A1 and A2. So A1 BD1 plus SD1 square, 10 into 1 plus 2 into 1 square, 12 square meters. A2 BD2 plus SD2 square, 10 into 1.60 plus 2 into 1.6 square, which is equal to 21.12 square meters. So from this we have to take average, we will get 16.56 square meters. So the area into length we will get 3312 cubic meters. So you can see the difference, there is not so much difference. Okay, now we will come to the method 3 prism model formula. So what it is, quantity is equal to L by 6 into A1 plus A2 plus 4AM, where A1 is what, 12 square meters. By method 2 only you can directly assume the values, A1 and A2 21.12. Now AM is, for AM we have to calculate DM. So DM is 1.30. So now add and substitute. So we will get the AM as 16.38. So quantity is equal to L 200 by 6. So A1, A2 plus 4 into AM, we will get 3288 cubic meters. So which is accurate one. The difference of the methods 1 and 3 is less than half percent. The difference by method 2 and 3 is less than 1%. So they are just shown how the values will come. Okay. So let us discuss another example. So calculate the area of the slide slopes. If the banking or turfing is required, pitching is required, then what? The example is on pitching. Okay. Calculate the area of the side slopes of portion of the bank for a length of 200 meters. Fine, L is equal to 200 meters. The heights of the bank at the two ends of being D1 they have given 2.50, D2 3.50, and the ratio of the side slope is 2:1. Fine. If the side slopes are to be provided with 15 centimeter thick, here see it is 15 centimeter thick stone pitching. Calculate the cost of pitching at the rate of rupees 150 per cubic meter. So first one what we have to find, calculate the area of the side slopes. Okay, the area of the side slopes we have directly have the formula here, where after the method 1. So see here we have the formula, area of the side slopes, it is D is equal to S square plus 1. This formula, D is equal to S square plus 1, and area of the two side slopes, it is equal to 2L into D into root of S square plus 1. If we multiply by 2L, it is the total area of both the side slopes. Now we'll come to the example. So calculate the area of the side slope of portion of a bank for a length of 200 meter. Okay, so mean height D is equal to 2.5 plus 3.5, we will get 3 meters. Now sloping breadth at the midsection. So the formula D is equal to root of S square plus 1, we will get 6.71. So area of the two side slopes, if we multiply this with 2L, we will get the area of the two side slope is 2684 meter square or square meters. Now for this area we have to find how much will be the cost, and the cost is given, the rate of cost is given, that is rupees 150 per cubic meter. So now quantity of pitching. So for quantity, area into what, length. For roads, for pitching, area into thickness. The thickness is already mentioned. Okay, area into thickness, what is the area, 2684 square meters into thickness is 15 centimeter. Okay, 0.15, that is equal to 402.6 cubic meters. So 402.6 cubic meters into the rate 150, we will get the cost of stone pitching as 60,390 rupees. This was an example for the cost, calculation for the cost for pitching. What are the data they have will give and how we have to find. Now we will see the example number 3. Fine. What they have given, reduced level of ground along the center line of a proposed road from chainage 10 to chainage 20. See here, chainage 10 to chainage 20, there are almost 10 readings are given below. Fine. The formation level at the 10th chainage, starting only for the formation level at the 10th chainage is 107. They are giving the formation level here only 107, and the road is downward gradient. Gradient is also given 1 in 150 up to chain age 14. Okay, station 4, chain age 14, and then the gradient changes to 1 in 100 downward. The formation width of the road is 10 meter, B is equal to 10. Slide slope of banking are 2:1, so S is equal to 2. Draw longitudinal section of the road, we have to draw, and typical cross section, and prepare an estimate of earthwork at the rate of 275 percentage cubic meter, and also find the area of the side slopes and the cost of turfing and the side slope at the rate of 60 square meters. Okay, they have given the chainage. So my dear students, see here, important problem it is. Now find the area of the side slope. Okay, so what they have given, chainage 10, 11, 12, 13, 14, 15, 16, 17 up to 20. So at that station, what is the RL of the ground? 105, 105.60, 105.44. These are all the RLs. Fine. Now they have given that RL of the formation at the 10th chainage is 107, and gradient is downward gradient 1 in 150 till chainage 14, and then downward gradient 1 in 100 up to 20. Okay, now you have to draw the cross section, okay, the banking and also the L section of the road. What we have to do, you just, what you do, if they ask you to draw, just take a scale of whichever you require as the page you have. Okay, take a scale and draw this one graph, or else you can see here RL of the ground, we have to note it down, the RL of the ground. Okay, now RL of the formation, this we need to calculate. We don't know RL of the formation, only one value at the 10th chain that is given. Okay, now so distance in meter, the chain edge is 300, 330. Okay, for every 30 meter, chain edge is 30 meter. Okay, the distance between the stations is 30 meter. Fine. Now see the gradient 1 in 150. What we have to do, we know the distance between the station is 30 meter, so 1 divided by 150, 1 divided by 150 into what, 30. So I am writing with the mouse, bit difficult. So what you have to do, 1 divided by 150 into 30, we will get the answer as 0.2. Calculate, you will get answer as 0.2. What we have to do, this 107.600 is there na, then we have to subtract 0.2 from this to get the formation level at the station 11, at the chainage 11. For 12 also you have to subtract 0.2, for 13 also you have to subtract 0.2, for 14 also you have to subtract 0.2. Then after 14 they have given, after 14 the gradient is 1 in 100. What we have to do, 1 by 100 into 30, we will get 0.3. Okay, 1 we will get 0.2, and after 14 we have to subtract. So for 106.20 we have to subtract minus 0.3, so 105.90. Then up to here we have to subtract minus 0.3. Okay, subtract 0.3, we will get the RL of the formation. Fine, we will get RL of the formation. Now we have to find the height of the bank. How to find height of the bank? Just subtract the RL of the formation minus RL of the ground. 107 minus 105, you will get 2. 106.80 minus 105.60, we will get 1.20. Like this, we have to find the height of the bank till the 20th chain edge. We will get 1.10. Then after, we have to tabulate them in the estimating form, which we have seen. Okay. So what we have: station, length, height, station 10 to 20. Okay. Length 300, 330, 360, 390, 420. This is given. Okay. It's given. Or they will give just the difference between the stations is 30 meter. Then at 300 meter, what is the difference, height or depth of difference of ground level and formation level is 2. Okay. Then the first row will be leave blank. Okay. Then from the 11th station or 11th chain edge, your difference starts. Now the mean height or 2 plus 1.2 by 2 we will get 1.60. The average of these two we will get 1.60. For this 1.60 we have to multiply by 10 as b is equal to 10 meter. Then side area s into d square. Yes, we have 2 into d square. What is the d we are getting? D square. For total sectional area, bd plus column number this 1 2 3 4 5 5 plus 6. So column number 5 plus 6 is the total sectional area. Next, length 30 meters. So we will get the banking. We'll get the banking value for this 633.6. Same. Now for 12th, what you have to do? 1.20 plus 1.16 divided by 2, we will get 1.18. Then 1.18 into 10, 11.80. Then s is 2 into 1.18 square, we will get 2.78. Then this both the column we will add, we will get 14.58. Then length in between the station is 30, we will get 437.4. Like this we have to calculate till 20. Then the total banking quantity we have to calculate, how much total we have got. Then we have to calculate the cost, abstract for estimated cost. So as we seen earlier, the abstract of estimated cost. Okay. Item number, particular of the item is earthwork in banking. Quantity we got 3513.6. Unit is meter cube. Rate they have given in the question as 275 per cubic meter. So 9662.40. And add 5% contingencies, 3% for contingencies and 2% for work charge establishment. You will be, then the grand total will be 10,145.52 rupees per cubic meter. It is the cost. Then calculation of area of the side slopes. So we will get, we know s is equal to 2 and we know the formula is root of s square plus 1, 2.236. So same stations or chainage we have to note it down. Same height, the difference which we got, then the mean height. This is also same column. Here we have to multiply d into s square plus 1. We will get this value. This is also starting from 11 as we are taking mean depth. Okay, length is 30 meter. Then area of the both the side slope. Okay, then the total area which we get. For this also they have given the rate, okay, at 60 per square meters. So 778.60, add 5% contingencies, 38.6, so 817.61 rupees per square meter is the cost